in immunocompetent patients. Docular surface is constantly exposed to pathogenic bacteria. Although normally we can find different types of microorganisms in the vagina, eyelids, and tears, bacterial infections of the human eye remain a major hazard that can cause visual impairments. Many numbers of bacteria have been indicated in ocular infections in immunocompromised patients. These microorganisms have in their fever a variety of areas to cause infection. The main ocular gram-positive pathogens are Staphylococcus aureus, members produce streptococci, Corynebacterium, multifarious species, and Bacillus erectus. The components of gram-positive microorganisms are peptidomic acid, glutathionic acid, and calcium polysaccharide are well known. Those components get involved in the pathogenesis of ocular infections by gram-positive bacteria as they trigger chemotaxis of inflammatory cells and cytokine production. Staphylococcus aureus is a major ocular pathogen. It belongs to gram-positive cocci. It has potent virulence factors in its absence. It causes infection of the black vasculature of that as items. With proteins and enzymes that promote bacterial adherents, such as microbiome A, hydrogen proteins, iron, hydrogen and glycolic acid. The cellular signal triggers the activation of NK and other systems. These pro-inflammatory cytokines induce keratinocytes to produce antimicrobial peptides like beta defenses, catholicity, RNase, cytokines, chemokines, adhesion molecules, granulopoiesis factors. As a result, neutrophils are recruited from the circulation, and those neutrophils create an access to the spread of infection and neutralize the invade. Staphylococcus aureus produces several toxins and enzymes that damage the host tissue and help invade the pathogen spread, and also attract and destroy the cells. Of those toxins, alpha-toxin, phytosoluble molecules, and pantopyrrolidine glucosamine induce host cell lysis. Chemotaxis inhibitory protein of staphylococcus extracellular adherence protein inhibit both carotenoid pigment and superoxide dismutase enzymes inhibit reactive oxygen species. Staphylococcus aureus protein A interferes with oxygen-phagocytosis involving beta cell death in vitro with the following mechanism of action. It binds the Fc region of antibody and the half regions of the beta cell receptor. Exfoliative toxins and toxins of syndrome toxin act as superagonists. They provoke detachment of ligaments and skin detachment. Staphylococcal leukotoxins. PPL has gathered much attention to which that we acquire and cell. Tumor cells are highly susceptible to leukotoxin. The PPL mechanism of action is formation of chromatic transmembrane pores in lymphocytes, mononuclear cells, and reticulocyte lysosomes. This includes response to human polymononuclears by aggregated UAB, a potential strategy employed by Staphylococcus aureus to avoid polymononuclear-mediated killing could be to seize polymononuclears and coordinate an offensive attack through the production of leukotoxins. Consistent with this supposition, Staphylococcus aureus has been shown to increase leukotoxin transport levels post-phagocytosis by polymononuclease. UKB has been shown to be critical cytotoxicity of supernatrants collected from both MCC and NRC lytic isolates to primary human phagocytes. It's required for Staphylococcus aureus survival in human whole blood. Protects Staphylococcus aureus from polymononuclease-mediated growth restriction. Contributes to Staphylococcus aureus-mediated killing of polymononucleosis. Protects fecal infection models. It is also responsible for Staphylococcus aureus-mediated killing of primary human monocytes, macrophages, and lymphocyte cells. Can also rise after phagocytosis. Those pose in the plasma membrane of polymononucleus, leading to polymononuclear lysis. Nucleate shares significant homology with the other staphylococcal toxins, including PL, has cytolytic activity toward human polymononuclears. Nuclease was highly expressed in polymononuclear phagocytosis. With other leukotoxins, as well as polymononuclears on the surface of susceptible target cells, such as neutrophils, monocytes, and macrophages, and can thereby alter the host cell function for phagocytosis. UV contributes to the lethality observed across Staphylococcus aureus bloodstream infection of both methicillin-resistant SROs, Staphylococcus aureus MSSA, and MRSA strain. Staphylococcus aureus produces coagulases, staphylocoagulase, and convivial factor. Those coagulases trigger conversion of fibrinogen fibrin. The formed fibrin clots mass to the surface of Staphylococcus aureus cells and thus inhibit phagocytosis. Staphylococcus aureus is related to post-traumatic and post-operative endophthalmitis with poor visual outcome. In the pathogenesis of Staphylococcus aureus endophthalmitis, toxins that are controlled by volume sensing system and that combination have been described. Those are accessory gene regulator and staphylococcal accessory regulator. As Staphylococcus aureus enters the vitreous cavity, its rapid proliferation triggers intense inflammatory response that avoids the blood ovular boundary and thus enhances further recruitment of inflammatory cells. In this interaction, the toll-like receptor 2 plays a major role in the pathogenesis of Staphylococcus aureus endophthalmitis. Aflatoxin is a complex factor in Staphylococcus aureus keratitis. It acts as a membrane damaging immunosome, which attacks the corneal epithelium. Staphylococcus aureus aflatoxin and beta toxin participate in retinal destruction. From the members of the genus Streptococci, Streptococcus pneumoniae, Streptococcus pyogenes, Enterococcus, and Streptococcus viridans are isolated from post-infection endophthalmitis cases. Streptococcus pneumoniae, in rare infections, is most important keratitis, conjunctivitis, and endophthalmitis. The microorganism firstly colonizes the nasopharynx via these neuraminidase. Then, due to hyaluronate-ase, which disrupts extracellular matrix components and increases tissue permeability, it invades in the deeper layer. Streptococcus pneumoniae strains that do not produce capsules with mutation or deletion of non-capsulated microbes are the target of most conjunctivitis cases. The pneumococcal capsule produce cytosine and C-reactive protein binding to the microbe, and thus the complement system is not activated and the microorganism escapes phagocytosis. The Streptococcus pneumoniae cells have the ability to observe lysis by secretions of autolysis. Autolysis may lysis non-complement pneumococcal cells, non-competent pneumococcal cells, and thus allowing DNA exchange by the healthy cells, reduces phagocytosis, and facilitates the release of other virulence. Pneumococcal is the candidate most often advanced due to the Streptococcus pneumoniae infection. Its mechanism of action is spore formation and promotes post-cell lysis. It also activates the classical complement pathway, provoking intense immune response. The pneumococcal zinc metalloproteinases, ZMP, and IgA1 protease GFP and GFPC have a distinctive role as wilderness factors. IgA is vital for adherence to host cells and helps neutralize IgA antibodies at the heme region. GFP provokes augmentation of human necrosis factor A, which enhances infection severity. GFPC removes the immune system from beta cells and binds to T-selective, frustrating neutrophil migration. Victors Thomas are also considered virulence factors as they contribute to the adhesion to the host cells. These adhesive are encoded by the pneumococcal RNA response. The Cryptococcus pyogenes is post-chronic hepatitis that acquired conjunctivitis relates to the intensive care group. The virulence factors of group A streptococci are mainly secreted proteins. Proteinases facilitate or enhance bacterial spread. Streptokinase has interactivity with host urokinase type and tissue type plasminogen activators, which means that converts inactive plasminogen to proteolytically reactive plasmin. As a result, post-matrix streptokinase are activated, and fibrinolysis, deletion of extracellular matrix, and basement membrane components of host tissue follows. By this mechanism, the microbe spreads to the surrounding tissues of the inoculation site. The sustained proteinase, streptococcal pyogenic, heterogenic toxicity or streptococcal sustained proteinase, degrades host flows of the immune response like cytokines, immunoglobulins, chemokines, catholicity, and complement components. Streptococcus pyogenes cell envelope protease, cleaves, and inactivates neutrophil chemokines. Streptococcus secreted esterase hydrolyzes platelet activating factor and mediating chemolysis in natural killer cells and neutrophils. The Streptococcus pyogenes secretes hemolysis, streptomycin O, and test. Streptomycin O is a cytotoxic that creates holes to cholesterol-rich host membranes. It's cell host. It's also made streptococcal NAD dehydrates in the cytoplasm of the cells. Once there, it leads the placental product. Utilizing no and polyethylene are the survival of Streptococcus pyogenes in macrophages. Streptolized food prevents acidification, whereas DNA is hydrolyzes NAD and prevents hydrolysis of Streptolized cells accumulate proteins in the host cell membranes, which form hydrolytic poles that lead to small lysis, which activity is related to lysis of lymphocytes, leukocytes, and proteins. DNA Streptococcus pyogenes the mechanism of action is the degradation of the nucleic extracellular matrix. Groups are DNA-based and prevent the bacteria not dependent on spread. But they are also exposed to antimicrobial agents and the bacteria's own living factors. The high neurokinesis secreted from Streptococcus pyogenes promote the ability of the microbe to spread through host tissue. Streptococcal inhibitor of problem inhibits the formation of the brain attack complex, which implicates cell lysis. This is falsifying the oxidative burst of glucose by converting superoxide anions to oxidative hydroxy peroxide. As a result, the matrix survives oxidative stress. The immunoglobulin degrading enzyme is a secreted sustained proteinase that keeps up the IgG. Thus, the streptococci resistant cytosis and antibody cytotoxicity. Next is removes carbohydrates from IgG. As a result, both the binding of IgG to the Fc receptors and both the regulation is reduced. This mechanism promotes the microorganisms. The endoprotein of Streptococcus pyogenes helps to resist phagocytosis by polymorphic leukocytes. The presence of quite specific antibodies to the antibody means resistant to infection from Streptococcus pyogenes. Enterococcus coecalis is indicated in post-ocular endophthalmitis cases. The strains produce a cytokine with a large red exantule and small white exantule. These are related with poor visual outcome. Corynebacterium non-bacterial species are normal occupants of ocular surfaces. They are opportunistic pathogens involved in the infections of the pathology, hematoplasy, and infection. They possess fluid with tissue tropism to colonize host tissue via the transvertibration test. After initial attachment, additional minor fillings help unveiling and provide proximity between the bacterial surface and the host cell plastic membrane. Bacterial species provoke conjunctivitis, keratitis, and post-traumatic endophthalmitis. Bacillus causes food poisoning and gastrointestinal disease. Local ignites skin and ocular infections and cause rapidly destructive endophthalmitis. In the nosocomial environment, the spores of Bacillus can be found in penetration, intravenous catheters, gloves and hands of the staff, endoscopy equipment and light, and can survive in alcohol-based hand wash solution. Many factors result in an intense inflammatory response that leads to vision loss in a few days from the onset of infection. The ability of the bacillus for rapid application and activation throughout the eye, as well as toxic production, has been described. The cytokine of the surface of bacillus reacts with toll-like receptor 2. The combination of toll-like receptor 4 and its adaptive molecules mediating triggers a group intraocular inflammatory response. The function of the bacterium will help the bacterium intraocular. It has not been determined the action of the plasma with toll-like receptor 5. Adhesions, including the teeth, have been reported as virulent factor of bacterial cellular infection. Experiments with feeling are better intraocular growth and infections of the in Bacillus endophthalmitis, the rapid vision loss is mainly due to the devastating results of the cytolysis and enzymes which the microorganism produces. Those include hemolysis, mutases, enterotoxins, and proteases. Hemolysis PL of Bacillus is a tripartite four-forming enzyme that gets involved at the early stages of inflammation. Senolysin A, B, and O, and collagenase are observed to play a role in the pathogenesis of endophthalmitis. Senolysin AB acts on cell membrane and has cellular activity. Senolysin O also provokes cell lysis in a two-step process. At first, it binds to cholesterol and then produces cell lysis. Collagenase targets the collagen which is abundant in the tissue. Concluding, a variety of gram-positive bacteria and ocular infections in non-immunocompromised patients. These pathogens have potent virulence factors that cause severe eye damage. They provoke direct tissue damage and interact mainly with components of the innate immunity. The outcome of the vacuum is accomplishment of blood-ocular barrier in the transcripted cells. The enlightenment of the mechanisms of infection caused by these pathogens is crucial in diagnosis and treatment as they remain major causes of visual impairment. Thank you for your attention.